GATE 2018 Civil Engineering Set 2 Question 41. A 6-meter long simply supported beam is pre-stressed as shown in the figure. The beam carries a uniformly distributed load of 6 kN per meter over its entire span. If the effective flexural rigidity EI equals 2 into 10 to the power 4 kN meter square and the effective pre-stressing force is 200 kN, the net increase in length of the pre-stressing cable needs to be found in mm and rounded off to 2 decimal places. The relevant NPTEL reference has been cited. Here we can see a simply supported beam which has been pre-stressed with a pre-stressing force of value P at an eccentricity of E from the neutral axis. The beam is also subjected to a UDL of value W. So the moment diagram of this beam can be drawn as follows due to the pre-stressing force, which will be negative and of a magnitude PE constant value. Similarly, the moment diagram due to UDL would be a parabola of positive magnitude. Due to these moments of PE and WL square over 8, the deflection diagrams of the beams can be drawn, which would be positive for the pre-stressing force moment, that is theta 1, and when we consider the UDL value of W and its moment, for that it would be negative and the magnitude of deflection would be theta 2 at both ends. Here we can see that theta 1 is upward and will have a value of the moment into length over 2EI. Similarly, theta 2 will have a value of WL cube by 24 into EI, where EI is the flexural rigidity of the given beam. Once we have these values, we can find the net deflection theta, that would be given as theta 1 minus theta 2, or it can also be written as theta 2 minus theta 1, depending upon the magnitude which is larger. So once the beam has been subjected to a pre-stressing force, it will deflect in shape, which would look like here. The net extension in length would be E theta for the pre-stressing cable on the left, and it will also be E theta on the right. This is obtained as where delta x would be equal to radius into the deflection. Here the radius is nothing but the eccentricity value, which is E, and theta. So delta L of the pre-stressing cable will be equal to 2 times of delta x, which is E theta. This would be obtained as 2E into theta. Here theta is the net change in deflection of the beam at either ends. In this question, pre-stressing force has been given as 2 kN, eccentricity is given as 50 millimeters. The UDL value has been mentioned as 6 kN per meter. Flexural rigidity of the beam is given as 2 into 10 to the power 4 kN meter square. Using this, theta 1 due to the pre-stressed force can be found, which will be equal to ml by 2EI. Here moment is nothing but P times E into the length divided by 2EI. On substituting the values, where P is 200 and should be substituted in Newton, so we will operate it with 10 cube into eccentricity, that is 50, and length would be 6000 millimeters for the whole beam, as it has been given as 6 meters in the question, divided by 2 times of flexural rigidity, that is 2 into 10 to the power 4. This should be converted into CGS units, that would give 10 to the power 9 as a conversion factor. This would turn out to be 1.5 into 10 to the power minus 3. This will be downward in direction. Secondly, theta 2 due to the UDL that we saw in the previous slide as WL cube divided by 24 EI. Substituting the values, W as 6, it will be the same in CGS, length which is 6000 cubed divided by 24 into 2 into 10 to the power 4, This should be operated with 10 to the power 9 to convert it to CGS units. The final value would turn out to be 2.7 into 10 raised to the power minus 3, which would be upward in direction as seen in the previous slide. Using these two values of theta, the net theta can be found, which will be theta 2 minus theta 1. Here theta 2 is 2.7 into 10 to the power minus 3. From this, the value of 1.5 into 10 to the power minus 3 should be subtracted. This would turn out to be 1.2 into 10 to the raised to the power minus 3. As we saw, delta L is given as 2 times of delta x, where delta x is the extension on each end, which will be E times of theta. Substituting the values, E is 50 mm and theta has been obtained as 1.2 into 10 to the power minus 3. This would give the value as 0.12 millimeters. So the net increase in length of the pre-stressing cable was found out as 0.12 millimeters. The relevant NPTEL reference has been listed.